Alright, recording. Okay. Projectile. This is my second time filming this because, unbeknownst to me, the battery died. Motion. Like the little drumming monkey thing. Okay, so we've got a wall and this can, and he shoots her. You want to know distance traveled. Here's horizontal. It's at some angle theta off horizontal, and it's got some velocity in the theta direction, and there's some height h that it drops. I think in the question it was like 30 meters, but for us we'll just say that it's h. So yeah. Alright, so first thing you want to do, understand that the vertical velocity and the horizontal velocity are completely independent of one another. The horizontal component has absolutely no relationship to time in the air. It's going to fall, hit the ground at the same time, regardless. All it has to do is the vertical component. So angles theta, velocity theta, like this. You can do them like this, okay? Triangle, v sub y, v sub x. Okay? So sine theta, v sub y over v sub theta. Alright? And then you'd solve that. Because this would be known and this would be known. Switching it over to x, you do cosine. So we're going to... This guy's amazing with his knife. Look at him. These are all known now. Velocity and the vertical component, the y one, this will be our initial. This time increasing this way. What is that thing? Look at it. It's a nasty little eating creature. Weird little thing. She likes it. It's going to start here and it's going to decrease. And at this point, it stops moving up and starts moving down. It starts getting in higher levels of speed in the opposite direction, the negative direction. Okay. At this point, this point here is where it falls back down to where it launched from. And if it was on level ground, it would hit the ground there. And then there's this extra drop. And this is our extra drop. So the area of inside here is distance traveled. In other words, rate times time equals distance, or velocity times time equals displacement. I didn't understand this one with the pug. This whole lot of slow motion and shots of this pug. I'm a pug. Yeah. But it is what it is. So, if you had a constant speed for a certain amount of time, and this was just like the velocity stayed at the same height, then you would just multiply this times this, and you'd be the area in here. Alright. That would be the distance, velocity times time. Alright, so if you had, velocity that increased at a constant rate, then velocity times time would be the area under the triangle. So b times t divided by t. Because the triangle is half of the box that it would make, then that's going to give you your distance traveled there. So the area of this triangle are the same because the distance traveled up and the distance traveled down are the same. And then there's the extra distance. And the area of that one is h. Alright? So, what's the equation for this line? Well, the slope of the line is the rate of change in velocity. And we know that it's losing velocity. Negative 9.81 meters per second for every second. Okay, which is acceleration due to gravity. 9.81. It's not really equal. We'll just say equals 9.81 meters per second squared. In our case, we'll just call that g. That's the slope of the line. For every movement in time, it goes down that amount. For every second, it goes down 9.81 meters per second. Okay? I'm just going to call it g. The slope of the line is g. So the equation for line equals y equals mx plus d. In our case, that's velocity equals g times time plus initial velocity. Velocity is 0. So we know this point because this point has no velocity. It's not moving up anymore, it's not moving down. Gt plus b sub naught is the initial Vy. This little baby is dancing, really. She really dancing. Do they have like a heavy jacket on the cat or something? I don't know. Anyway, so there's, you plug that in, and that'll give you the time here. You know, you subtract, you some y over, and then you divide by g. Remember, g is actually negative 9.81, so the negatives cancel, and you're gonna get some time, and we'll just call that t sub 1. Okay, this is scary right here. Whoa! I mean, it's like really scary. Anyway, since the area, the distance traveled up and the distance traveled back down, at least to where it was shot from, are the same thing, then we know that this is just 2 t sub 1 to here. We know that, in other words, since the slope of the line stays the same, and the area of the triangle is the same, then obviously the distance to here and the distance between here and here are the same. So what we want to know is the time to here, at this point. And this gets a little more complicated. But just adds extra little complication. Okay, but what we can do is, boom, draw ourselves a triangle. Okay, we know the area of this one is 30, or actually, area is h. This angle, don't know what it is, but we do know that this distance is 2 t sub 1. Okay, so we can find this height because, remember, change in x over change in y equals the slope of the line, which in our case is acceleration, which is g, which remember it would be supposed to be a g, it's 9.81. So he actually makes it up this hill. That is incredible. Anyway, we know that basically this is pretty, it's like the Tai Chi dog. Anyways, G is basically for every, it's 9.81 meters per second, because the height of this would basically represent velocity, if you remember. It's velocity on here, then the height, you know, that's terrible wrong. The height between here would just be velocity. So this is basically velocity, whereas this height is really that initial h, that displacement. Okay, per second. So you have 2t1 seconds. Alright, so you're just going to multiply 2t1 times this, times your g, and that's going to give you that. So we'll call that little h. Okay? Hopefully that's not too confusing. But we'll call that, v sub 2. I'm about to make it a little less confusing. Okay, so now that we have this side and this side, we can figure out this angle. But we don't have to, I think. We can figure out, let's just figure out this angle. We'll call it alpha. So the tangent of alpha equals opposite over adjacent, so Cotola, v sub 2 over 2t1, opposite over adjacent. And if you do tangent inverse of each side, that means alpha equals tangent inverse of v2 over 2t1. Okay, so that's what that is. That means alpha. Oh man. This guy is taking his life. He's really trying to get a lot of wood cut, isn't he? Is he trying to get paid extra or something? Does he own the place? Does he want to get off early or something? He must get paid by how many boards he cuts. No, that's gnarly. He gets it out too. He gets it out. That's a tough man. That's funny. Got that hair on his head. The treadmill's like running.
Oh my God. Who did that?
This is real funny with the little puppy.
Who did that?
Who did that? She comes over here.
Mike. Who did this? Did you do it, Mike?
No, I just I don't care. He just totally eats a lot of crap. So we'll call this beta, and we'll call this distance x. What we really want to know is x. So there's a few ways to do it. We'll do one way. This is a 90-degree triangle, and this is a 90-degree triangle. Anyways, let's see. Well, we do know that the ratios, this angle is the same. So what that means is the ratio of the triangles would be the same. In other words, this side over this divided by this side is the same thing as the larger triangle side divided by this little side. He just got his cat to that song. This person doesn't even make it at all. Anyways, so this is unknown and this is unknown. All these others would be known, but we can solve and get an equation. cross multiplying by. So 2t1 beta equals v2 times x plus 2t1. So you've got an equation with two unknowns, this and this. You can't solve that, but if you have another equation with this, you can solve it. You can do another equation where you say the area of the whole thing would be beta times 2t1. In other words, this side times this side divided by 2 equals the area of this one and this one. Interestingly, the 2's cancel, so it could just be that. And then added 30 because we know the area of that's 30. So the area of this one is that. It's not 30. It's h. Okay. So this is it. b2 2t1 over 2 plus h. Hey, boy, this is crazy. Her fake eyelash is burnt up off her face. I ain't seen this one. Alright, so if we solve this out, you know, and reduce this down. You going, man? Alright. Sorry I'm sitting here doing physics all the time. That's really weird. Okay, that's really weird. Anyways, so there's weird things on the computer right now. Anyways, I gotta turn that down because that's distracting. That's really distracting. Okay, so you've got an equation here, you know, you multiply this out, yada yada, you get like 2t1 beta plus x beta, and this one's divided by 2, 2's cancel, and then the other one's divided by 2. Alright, those are betas, not b's. Equals v2 t1 plus h. And so again, you've got an equation here with your two unknowns, your beta, your x. And so you just solve that in terms of just like anytime you have two equations, two unknowns. So look up two equations with two unknowns, whatever. And so when you have that, then you know it's kind of these equations from 8th grade. Something like that, minus x plus 14y equals 19. Okay. But in one of those equations, it was a little more like this. You had like xy, which in that case, you would divide this side by y and divide that side by y to get the y's. 19 divided by y equals, you know, negative x plus 14, and then do what you had to do to flip everything around. I'm just gonna assume you know that algebra. Once you know that algebra, then you're able to solve for that x and that beta, but you don't really need the beta, you need the x. And then that x is, you've got this would be x. The extra time, remember this was time, this is velocity, y, velocity. We knew the time to here was t1, we knew the time to here was 2t1, so the extra time is the x, so total time equals 2t1 plus x, which means that to get the total distance traveled, we just do v sub x times the total time, which is 2t1 plus x equals displacement in x direction. Thank you. That's physics problem for Blake. I guess if we want to, I can show a little bit. I can show that algebra from before. This was whatever the heck, I don't even remember what I called that. I remember I called that alpha, and that was 2t1. And this is x, and this is beta. I don't remember what I called this. Let's call it gamma. Okay. So we did the ratio thing, and we had the other area equation, where area equation was gamma times 2t1 to the area of this, and then we knew the area of this was big H. This big H equals the area of the whole thing, which is beta times 2t1 plus x. About 2. So this right here, let's reduce that down. That's gamma t1. And alright, so and the other equation was just the ratio equation where we had gamma to t, 2t1, beta is to x plus 2t1. In other words, these are similar triangles because this angle's the same and this angle's the same. Then the other angle has to be the same because all the angles of the triangle have to add up to 180 degrees in any triangle. And when you have two angles the same, that means that the ratios of the sides, like this side to this side divided by this side, will be the same thing as this side divided by this whole side. So then we cross multiply and we get 2t1 beta equals, just the easier way to remember, just this times this equals this times this, gamma x plus t1. Alright, so what we need to solve for is x. X is all we really care about. So we're going to use this equation because this is the easiest one. All we do is just say beta equals what we had on the other side, gamma times x plus 2t1, and then divided by 2t1. Okay. And remember, 2t1 and gamma, they would all be numbers, but I'm just doing it in terms of variables. And x and beta are your only actual unknowns. And so once this is solved out, then you know what beta is as an equation that equals x, which really would be, it would just be, really this equation, because we know all this, it would really just be some constant times x plus another constant plus another just number. Just some number we knew and some number we knew it equals. So we could do it like that. And so then we come back to our other equation and we get Oh, gamma times T1 plus H, I mean, really, we know what those are. But those are all just numbers, so we can just call that number, right? So some number. Number equals beta, we'll substitute, we know that beta equals, you know, that thing we came up with. So Cx plus K, substitute that in for beta, times 2T1 plus X, all divided by 2. And so now you have a bunch of numbers in X. So like, I mean, it would come out to like this. Let's just go up with it a little bit. You multiply by 2, you get 2 num, okay, equals C plus 1. Oh no, you got to multiply this up. Ugh. You're gonna get a quadratic. I forgot we get a quadratic. Yeah. That's okay. It's quadratic. Anyways, so square the front, square the back, twice the product of the 2. So you're gonna get. Ooh. I probably should have done it another way where we didn't get a quadratic, but it's okay, it's okay. This times this, Cx plus 2T1. And it would be some number. So we'll just call it C prime. It would just be some number, C prime X plus this times this, which we'll just call that K prime, whatever it comes out to be, and then this times this, plus that would be KX. That's terrible. KX. Oh, and then the 2 of them plus CX squared. So, to solve a quadratic equation, in other words, because we have x squared and x is a quadratic equation, to solve that we have to use quadratic formula. We have to get it in quadratic formula form, which the form is 0 equals some. Hopefully you know how to move these around and make this happen, but you know what you got to get it into the form of is 0 equals. Quadratic form 0 equals some constant 1 times x squared plus other constant, whatever it is, x plus this constant. Okay? And then the quadratic equation is x equals minus b minus o. Maybe I should do it with the minus b and stuff. Linear algebra. B, A, B, C. That's minus b plus or minus square root plus or minus square root b squared minus 4ac squared minus 4ac all over 2a. Two-way. Anyways, so like, whatever's under the square root or under the radical, it better be positive. If it's negative, then your answer doesn't make any sense. That means you made a mathematical error somewhere, because it's a physical reality question. Your answer, it's not like it's illogical for a ball to be able to fall, you know, that height, you know. So in other words, if you did all the numbers right and you got a negative under here and you're trying to take the square root of a negative, that would mean that like your physical reality doesn't make sense. We know the physical reality does make sense. So that just means if we get a negative under here, it means we made an error somewhere. You get a plus or a minus, so that means you get two possible answers, and one of them's going to make sense and one of them's not going to make any sense. One of them will probably be like a negative time, and you just throw that away, and it's the other time. There's probably another way to solve it that doesn't involve having to use quadratics. Let's see if we can find another way to solve it. Let's go back here. We call this gamma. We call this alpha. Okay. Well, we could find this side of the triangle, because this side of the triangle, we'll call it, I don't know, bread. Okay, so bread, this old Pythagorean theorem, bread squared equals 2t1 whole thing squared, not just t1, 2t1 squared, plus gamma squared. Okay, and so these are all knowns. You're just going to solve for whatever that is. So what that means is that we have a, let's see, yeah, we could do the ratios thing, because these two angles are the same. They're both 90 degrees. That one's the same. This is like a shared angle here, and then this one would be the same as that one. Then we know that the ratios of like this side to this side is the same as this side to this whole side. But also, this side to this whole side is the same as, the ratio of this side to this side is the same as the ratio of this whole side to this whole side. And we're still going to have to do something knowing that the area of this is h. Maybe we can get away with the fact that, like, we can make another triangle here, and because this line is parallel to this line, and this line is itself, we know this angle here is alpha. So maybe that helps us somehow. Just trying to find a more elegant, less clunky way to not have to do quadratics to solve this. Let's see. So in other words, gamma times x plus the area of this triangle equals h. And that's not all that helpful. We could just do what we did before and get that. Let's see, what we did before, we can't really use, oh, we could find the other angle. All the angles of a triangle add up to 180, and so this one's 90, and then the other one's alpha, and so that equals, we'll call this theta, and so this is theta, and so we do know that.